we interrupt our program of dance music to bring you a special bulletin from the Intercontinental Radio News. Reports observing several explosions of incandescent gas occurring at regular intervals on the planet Mars.
Thrilling listeners, in the 1930s, War of the Worlds marked the start of our modern fascination with Mars. But it's a planet we've been studying since the Age of Babylon. And for all the fever dreams of little green men, the chances of life on the red planet have always been thought slight, because we've never found liquid water there until now.
We are here today to present you our results and the fact that we have found liquid water in on the subsurface of Mars.
A lake seen here in an artist's impression and discovered by the European Space Agency scientists examining signals from Italian radar on the European Mars Express probe. It is 20 kilometers across, long hidden from telescopes beneath the red planet's south polar ice cap. Found using signals bounced off the surface and subsurface of the planet, the discovery raises a new hope of life.
If this is actually a liquid water lake, then potentially we could drill into it and see if there is any life in there, and it would more than likely be just purely microbial. That would be really, really exciting, but I think before we start designing and sending a mission to Mars to drill into that lake, we need to definitely confirm that it's there and probably have a good think about how we make sure that we don't contaminate it with any life from the Earth that we take up there on the drilling equipment. So there's an awful lot of challenges in there for further investigations.
Great science fiction tells us that the only liquid water we will find on Mars will be man-made. But these preliminary findings tell a different story and raise the hope once again that we are not completely alone in the solar system.
Well, joining us now via the internet is astrobiologist Dr. Manish Patel, who's currently in the Nevada desert where he's conducting Mars-related research. And with me in the studio is Tom Kearse. He's an astronomer based at the Royal Observatory, Greenwich. Let's just start with you, Tom Kearse. I mean, since certainly 2012, there's been talk of water on Mars.
That's right.
Is this definitive?
So whether or not this is definitive is actually, it's a little bit more complicated. What we've talked about in the past, to a greater or lesser extent, is surface water. But water on Mars is very challenging. You couldn't take this glass of water to Mars. It would sublimate into the atmosphere. There's not enough atmospheric pressure to keep the water as a liquid. Now, if the water is underground and if the temperature is about right and if the water is very saline, then it's possible that there could be liquid water there. This has been long suspected. What this finding shows us is that we're, I would say, very close to conclusive finding of a large body of water. I think there's still some further observation required, but it's the best explanation for the signals that the Mars Express spacecraft has picked up.
Well, I'm going to come back to look further at that lake, but I want to speak to you now, Manish, about what the water might tell us. You're an astrobiologist, and therefore I'm assuming you are looking for cellular life.
Yeah, hi everyone. That's the aim. This is the ultimate aim, is to look for signs of life on Mars. The big stepping stone to doing that is to finding environments, habitats on Mars that could support life. The key thing we've been missing up to this date, as Tom said, is liquid water. At the surface, it doesn't exist. Finding this proposed liquid water below the surface gives us a habitat where life could exist. I say could because we don't know if there's life there. There might not be life there, but the opportunity is there. It's kind of, X marks the spot type of stuff.
We think there have been some sort of movements in the water in the past, do we not? I mean, perhaps not microbic, perhaps little explosions from emitted gases.
Yeah, we know that water has played a big part in Mars's history. If we look at the surface from orbit, we can see these huge valleys and features carved by the movement of water, fluid, at the surface. So we believe that Mars had a lot of water at its surface in its ancient past, billions of years ago. It's lost that water as it lost its atmosphere. And the big question is, where did that water go? Is it possible that some of it retreated underground? We know that there's ice in the subsurface of Mars across the whole planet. So the question has been, is there a point, can you go down far enough where this ice becomes water, or does it just go straight from ice to rock? And this seems to indicate that there is a zone of water below these ice caps.
OK, I'll come back to you in a moment, because, Tom Kearse, I wonder, now that we think there might be water, where do we go from here? What further research could be done? What is feasible, given what you know?
Well, a lot of research has been done on Mars. We have orbiters like Mars Express, which are capable of surveying the poles.
Which was involved in this discovery.
Involved in this discovery. Very clever, using radar to probe beneath the surface through the ice. But we also have rovers on Mars, including the Curiosity rover and the Opportunity rover, both operational right now.
Are they heading for the spot?
Unfortunately not. They're both thousands of miles away, so it'd be really difficult. They don't move very fast either. But the European Space Agency is going to be sending a semi-autonomous rover to Mars in the year 2021, which is currently called the ExoMars rover, but there is actually a public competition to name the rover right now. And unfortunately, Spacey McSpaceface has been ruled out. Otherwise, I think that would have won by a landslide. That rover, though, is going to be drilling underground up to 2 meters and sampling Martian soil. And really, with its instruments on board, that is expressly an astrobiological mission. That's something that Manish will know a lot about, because that rover is designed to take samples with the express purpose of actually looking for life signatures, whether present, perhaps more likely past life signatures, or just probing the subsurface environment to find out what its habitability might be like.
Well, Manish, what sort of life might this probe manage to reveal? I mean, you've already said probably not cellular as we know it.
That's the $1 million question, I guess. What we hope to find cellular life, but it's highly unlikely. I think personally, what I think we'll find is traces of past life, organic remnants, possibly traces of cells. But I think when we talk about life on Mars, we're really talking about microorganisms, so microbes, that kind of level of biological activity. ExoMars 2020, as Tom said, is going to drill below the surface, trying to get into this protected environment where you're protected from the harsh sunlight, harsh radiation, and pressure and temperature is a little bit higher. But it's really looking for signs of these organisms either being present in the past, so looking for their fossil remnants, or looking for the signs of their activity in the surface material below.
Well, OK, so, Tom, can you pick up on that?
Yes, so, well, when ExoMars finally arrives, that's going to be, if you like, the next ground-based step of exploration on Mars. But, of course, there is a long-term ambition to put human beings on the surface of Mars, and it's safe to say that one paleontologist given a day on Mars and a few tools could probably do more work than every ground-based experiment on Mars thus far, because robots, unfortunately, are very slow, and they have to be safe. They have to continuously tell us what they're doing. ExoMars is a step in the right direction, because this rover will be able to make its own decisions to some extent about how it traverses the landscape. So it's going to get around much more quickly relative to what's been sent before. But perhaps in a few decades' time, it will be feasible to put human beings on Mars. And unlike with the Moon, where it was really a race involving test pilots and 2 countries, we hope that we would see an international endeavour, and that the first people to go to Mars would include scientists who would actually be going there to study the potential astrobiological environment. Let
me ask you a current question. How much longer will Britain be involved if Brexit comes?
That is a question I actually don't know the answer to at all, I'm afraid. I would like to think that... What a diplomatic
don't know.
I'd like to think that we would continue to be involved, as well as mentioning that the UK Space Agency is overseeing the naming of the ExoMars 2020 rover.
Manish, you wanted to come in?
Yeah, I can answer that one. Luckily, well, from my personal perspective, luckily the European Space Agency is a separate legal entity to the European Union. So the UK remains involved in all of the European Space Agency missions, thank God. The problem is Brexit means that we won't be able to access the same pot of money, the EU pot of money, to exploit the science. So we'll still be involved in the missions. We're still going to build instruments to go to Mars. We're just going to have to find an alternative source of money for the science.